I hope all of you are doing good. Let's start today's chapter, Understanding Quadrilaterals. After reading this chapter, you will be able to know about all these topics. So let's get started. Introduction. Any four-sided closed figure is called quadrilateral. We all know that. If A, B, C and D are four non-collinear points and the line segment AB, BC, CD and DA do not intersect except at their endpoints, then the figure formed by these line segment is called quadrilateral. Okay, non-collinear points means points which are not in a same line. Okay, the points A, B, C and D are called vertices of the quadrilateral. See, this is the quadrilateral A, B, C, D. So these are the points A, B, C, D. These are the vertices of the quadrilateral. A quadrilateral is named by listing its vertices starting any vertex and reading clockwise or anti-clockwise. Means you can write this name as A, B, C, D or A, D, C, B. You can start from any point. It's totally up to you. Okay. Polygons. A simple closed figure consisting only line segment is called a polygon. Okay. Now, classification of polygons. Polygons can be classified according to the number of sides or vertices which are as under. If there are 3 vertices, the classification is triangle. If 4 vertices or 4 sides, then it is quadrilateral. 5 sides, pentagon. If there is 6 sides or 6 vertices, then hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. And 10 sides, decagon. Okay, and figures are also given here. Diagonals. A line segment connecting the 2 non-consecutive vertices of a polygon is called diagonal of the polygon. Means if this is a quadrilateral A, B, C, D connecting 2 non-consecutive vertices. Okay, see, these are the consecutive vertices and D and B, these are the non-consecutive vertices. This is the diagonal and this is also the diagonal, right? No more. If a polygon has n sides, then total number of line segments including the sides of polygon is this. Formula is given n, then in bracket n minus 1 by 2, n square minus n by 2, and b total number of diagonals if you have to find out. So this is the formula. Okay. Convex and concave polygons. Can you differentiate between convex and concave polygons? Here figures 1 and 2 are concave polygons and figure 3 is convex polygon. Differentiate convex and concave polygons from the following figures. Okay, see, these are the figures we have to differentiate which are convex and which are concave. So let's first learn the difference between convex and concave polygon. Number 1, a convex polygon can also be defined as a polygon in which all interior angles are more than 0 degree but less than 180 degree. None of the interior angles is the reflex angle that is more than 180 degree, right? On the other hand, concave polygon has at least one or more interior angles as reflex angle, an angle more than 180 degree and less than 360 degree. Number 2, the polygon in which all the diagonals entirely in the interior of the polygon are called convex polygons. And number 2, in a concave polygon, some portion of one or more diagonals lies in the exterior of polygon. Okay. Now, regular and irregular polygons. A regular polygon is one in which all sides as well as all the angles are equal. That is, a regular polygon is equilateral as well as equiangular. Are you getting it? Regular polygon is equilateral as well as equiangular. For example, an equilateral triangle is a regular polygon of 3 sides. A square is a 4-sided regular polygon. Can a rectangle be called a regular polygon? No, because though all angles are equal, here your opposite sides are equal but not all sides. That is, adjacent sides are not equal. Can a rhombus be called a regular polygon? Why or why not? No, it is not a regular polygon because all sides are equal but all angles are not equal. For a regular polygon, it should have equal angles, it should have equal sides, right? Maths extension. In a polygon, equilateral means all sides are equal, equiangular means all angles are equal, and regular figures means all sides and angles are equal, right? Properties of polygons. A. Angle sum property. We know that sum of 3 angles of a triangle is 180 degree. We can make use of this result to find the sum of interior angles of any polygon. Let us take any quadrilateral ABCD. If we draw one of its diagonals, say AC, this divides a quadrilateral into two triangles, namely ABC and ACD, and sum of interior angles of each of these triangles is 180 degree, and hence sum of interior angles of quadrilateral is what? 360. Hence, we conclude that the sum of the angles of a quadrilateral is 360 degree. Remember that. Okay. B. Exterior angle sum property. If the sides of a quadrilateral are produced in order, the sum of the four exterior angles so formed is a 360 degree. This property can be proved by cutting and pasting method. Okay. So here the procedure is given. Extend all the four sides of quadrilateral in order, that is in same direction, either clockwise or anti-clockwise, like in this figure. Here in figure 1, all are extended in anti-clockwise. Okay. And make a replica of angle 1, angle 2, angle 3, angle 4. That is all exterior angle, and set them as shown in figure 2. So what will we find? We will find the sum is a 360 degree, because if you look it carefully, it is a circle, and a full circle is of 360 degrees, right? Let's do example 1. Two sides of a quadrilateral are of measure 60 degree each, and the other two angles are equal. Find the measure of these two angles. Okay. So we will let the two equal angles be x, okay, and two other angles are 60 degree each. So by angle sum property of quadrilateral, what we have learnt here, the sum of the angles of a quadrilateral is 360. Two angles are equal, x plus x, and two angles are of 60 degree. 60 degree plus 60 degree is equals to 360, right? 2x plus 120 degree is equals to 360 degree. So 2x is equals to 360 minus 120 degree. 2x is equals to 240 degree, and x is equals to 240 divided by 2 is 120 degree. Okay. Hence measure of each of the angles is 120 degree. Similarly, you will do example 2 also. Here ratio is given of a quadrilateral, angles of quadrilateral. So you will let the measure of angles be 2x plus 3x plus 6x plus 7x is equals to 360 degree. Okay. Let's do exercise 3.1. Classify the following polygons as convex polygon and concave polygon. Okay, students, you can easily classify them. So you will do this by yourself. Kinds of quadrilaterals. On the basis of sides or angles of a quadrilateral, it is given specially. Number 1 is trapezium. A quadrilateral in which one pair of opposite sides are parallel to each other. See, this side is parallel to this side, okay, and this is not a trapezium, this is trapezium, this is not a trapezium, right? Try these, find x and y in the following trapeziums. Okay, two trapeziums are given here, we have to find the value of x as well as y. So here we have given 100, this angle D is 110, angle B is 75 degree, and x and y are not given. Okay, so first we will find, either you can find x or either you can find y. Okay, so angle A plus angle B is equals to 180 degree. Angle A is y, angle B is 75 is equals to 180 degree. Okay, y plus 75 is equals to 180 degree y. You know, if you remember, sum of adjacent angles are supplementary, right? That's why we have written here 180 degree. Sum of adjacent angles are supplementary. Supplementary means 180 degrees. Okay, so y is equals to 180 degree minus 75 degree, and y is equals to 105 degree. So now we have got this angle 105 degree. Now you have to find x. You can easily find out x. 110 plus 105 plus 75 plus x is equals to 360 degree, because by the angle sum property of quadrilateral, okay, the sum of four sides of a quadrilateral is equals to 360. Now you can easily find out this x. See, okay, now we have angle D is 110 plus we have this 105 plus this is a 75 degree plus x is equals to 360. Okay, you will add these up okay, and then you will subtract from 360. In this way you will get angle x. Okay, similarly in this question also you will find the value of x and y. Now kite. Kite is a special quadrilateral. The adjacent sides in pair are equal as shown in the figure with the same sign. For example, in quadrilateral PQRS, PQ is equals to PS and RS is equals to RQ. Second, PR is perpendicular to SQ. Third, ST is equals to TQ but PT is not equals to TR. Four, angle PSR is equals to angle PQR but angle SRQ is not equal to SPQ. Okay, see in this picture, right? Equal. This side is equals to this side and this side is equals to this side, but this is not a kite. So number one, a kite is a quadrilateral with exactly two pairs of equal consecutive sides, that is adjacent sides. Number two, the diagonals of kites are perpendicular to one another. Number three, only one of the diagonals bisects the other. And number four, only one pair of opposite angles are equal. Okay, now let's learn about parallelogram. A quadrilateral in which both pairs of opposite sides are parallel to each other is called parallelogram. For example, in parallelogram, this PQRS, PQ is parallel to SR or RS and QR is parallel to PS. Okay, this is the sign of parallel. Similarly, in parallelogram QUIT, QU, as you can see, QU is parallel to TI and UI is parallel to QT, right? Elements of a parallelogram. In a parallelogram, there are four sides and four angles. Of course, if there are four sides, then there will be four angles. Also, there are two diagonals, okay? In the figure RISK, that is RISK, this is a parallelogram. Here, RI and SK form one pair of opposite sides. See, RI and SK. And IS, that is this side, and RK, this side, form another pair of opposite sides. RI and IS are adjacent sides. SK and RK are also adjacent sides. Can you name other pairs of adjacent sides? Similarly, angle R and angle I. This angle and this angle are adjacent angles, and so are angle R and angle Q. These are adjacent angles. Okay. So name other pair of adjacent angles. Other pairs are angle K, angle S, angle S, angle I. These are the adjacent angles. Okay. Now let's check about properties of a parallelogram. Number one, both the pairs of opposite sides of a parallelogram are of equal length. Number two, both the pairs of opposite angles of a parallelogram are of equal measures. Number three, the adjacent angles of a parallelogram are supplementary, that is, sum of two adjacent angles is 180 degree. Number four, the diagonals of a parallelogram bisect each other at the point of intersection. Okay, let's do example 4. In a parallelogram CLUE, angle U is given 70 degree and we have to find out all the other angles. Okay, angle U is equals to 70 degree. It is given. Now this is also 70 degree. Why? Because opposite angles of a parallelogram are equal. So angle C is equals to angle U, which is equals to 70 degree. That means angle C is equals to 70 degrees. Okay. Now angle L and angle U. Angle L or angle U are supplementary, being adjacent angles of the parallelogram. Or you can also write like angle C plus angle L is equals to 180 degree, because the sum of adjacent angles are supplementary. Okay, so here you will take angle L plus angle U is equals to 180 degree. Reason, because these are adjacent angles and adjacent angles are supplementary. Angle L is, we don't know what is angle. Angle U is 70 degree is equals to 180 degree. Angle L is equals to 180 degree minus 70 degree. Angle L is equals to 110 degrees. Okay. Now this is 110 degree. Now angle, what is this? This is E, angle E. Angle E is also equals to 110, because angle L is 110 and opposite angles of a parallelogram are equal, right? So angle E is equals to 110. Okay. Let's do exercise 3.2. Number 1, the sides of a pentagon are produced in order and the exterior angles obtained out of measures these. x degree, 2x degree, 3x plus 10 degree, 4x plus 5 degree and 5x degree respectively. Find the value of x and measure of each exterior angle of the pentagon. Okay. See, as we learnt before that the sum of the exterior angles of any figure is equals to 360 degree. So, here x degree plus 2x degree plus 3x plus 10 degree plus 4x plus 5 plus 5x degree is equals to 360 degree. Reason sum of exterior angles is 360 degree. Okay. Let's add x plus 2x plus 3x plus 4x plus 5x, then 10 and 5 plus 10 plus 5 is equals to 360 degree. Okay. X plus 2, 3 plus 3, 6, 10 plus 15 x. 10 plus 5, 15 is equals to 360. Now 15x is equals to 360 and we will transpose it here. So 15x is equals to 10 minus 5 is 5, 5 minus 1 is 4, 345 and x is equals to 345 by 15. 5 2s are 30 and 5 3s are 45. Now the value of x is 23 degree. Now you will put value of x in this and this also, in this also, and this also. Only then you will get the answer. Okay, so let's do it. So first you have x, you have 23. Now next is 2x, that is 2 into 23 is equals to 46 degree. Next is a 3x plus 10. 2 into 23 plus 10. 69 plus 10 is equals to 79 degree. Okay, this is next is 4x plus 5. 4x plus 5. 4 into 23 plus 5. 92 plus 5 is 97 degree. And the last one is 5x, that is 5 into 23. 5 3s are 15, 105. Now you can check your answer by adding all these angles. If you get 360, that means your answer is correct. Okay, so let's add them up. 23, 46, 79, 97 and 115. 6 plus 3, 9, 9 plus 9, 18, 18 plus 7, 25 plus 5, 30, 3 carry. 3 plus 2, 5 plus 4, 9, 9 plus 7, 16 plus 1, 17 and plus 9, 26, 2 carry. 2 plus 1, 360 degrees. So that means your answer is correct, right? Some special parallelograms. Number 1, rhombus. Rhombus is a quadrilateral in which all 4 sides are equal. In fact, rhombus is a special parallelogram in which all sides are equal. Hence, all the properties of parallelogram are also the properties of a rhombus. But rhombus has one additional property. The diagonals of a rhombus are perpendicular bisectors of one another, that is, they bisect each other at an angle of 90 degree, and diagonals are bisecting the angles of all the 4 vertices. Okay. Next, a rectangle. A rectangle is a parallelogram with equal angles. Let us try to find the measure of each angles of a rectangle. We know that sum of 4 angles of a quadrilateral is 360 degree. Let each angle of the rectangle be x, then 4x is equals to 360 degree and x is equals to 90 degree. Thus, each angle of a rectangle is a right angle. Again, the rectangle has all the properties of parallelogram, such as opposite sides as well as opposite angles are equal and diagonals bisect each other. But in rectangle, diagonals are also equal. Okay. Next, a square. A square is a rectangle with equal sides. That means a square has all the properties of a rectangle along with one additional property. Diagonals of a square are perpendicular bisectors of each other, and they are the angle bisectors of angles of all the 4 vertices. Okay. See, ABCD is a rhombus, and angle ABC is given, which is 116 degree, and we have to determine angle OCD. That means this angle. Okay, let's do it. See, angle ABC is equals to angle ADC because opposite angles of a rhombus are equal. So So angle ADC is 116 degree and ODC is half of angle ADC. So half of 116 degree is 58 degree. Okay. Now we in triangle ODC, which is this ODC, you know the angle sum property of a triangle, the sum of all the angles is equals to 180 degree. Okay, this one is given, this is 90 degree. So we'll write here angle ODC plus angle DOC plus OCD is equals to 180 degree, that is angle sum property of triangle. 58 plus 90 degree plus OCD. Okay, now we can find OCD, angle OCD is equals to 32 degree. Okay, let's do exercise 3.3. If the diagonals of a rhombus are 12 centimeter and 16 centimeter, find the length of each side. Okay, so here diagonals are given, we have to find the each side, length of each side. Okay, so this is a rhombus A, B, C, D. Okay, diagonals are given. These are the diagonals. This is the point of intersection. We can consider it as O. Okay, this side is 12 centimeter and what is the other one? 16 centimeter. Okay, now AO, you know AO is equals to half of AC. So AO is equals to what is AC? AC is 16 centimeter. So AO is equals to 8 centimeter. Okay. Now similarly BO is equals to half of BD. So BO is equals to half of 12 centimeter, that means 6 centimeter BO. Okay. Now AO is 8 centimeter, BO is 6 centimeter. From here we will find AB. So AB square is equals to AO square plus OB square. Okay, from Pythagoras theorem. Okay. Now AO is what? 8 square plus 6 square. Okay, 64 plus 36 is equals to 100, means AB square is equals to 100, right? And 100 is square of what? 100 is square of 10. Square goes. So AB is equals to 10 centimeter. That means length of each side is 10 centimeter. Right, students? I hope you have understood this chapter. Now you will do practice of this chapter.